Hello, this is Mrs. Dowell, and I would like to talk to you today about how to graph a parabola that is in HK form. Now, this is a very good thing. HK form is in vertex form. We are very happy when it's in vertex form because we are able to look at our equation and identify quickly what our vertex is going to be. So let me just show you what HK form looks like. Y equals A, X minus H squared plus K. That will help you to identify what values are what. In our example here, A is 2, H is 6, and K is 3. Now 2 is really only used to help us to determine whether the parabola opens up or down. In this case, A is positive, so my parabola will be opening up, which means that I will be having a minimum Y value located at 3. So I'm going to put a grid on here, and I'm going to plot my H and my K with this being the x-axis and this being the y-axis. The H, I should say the vertex is 6, 3. So that means 1, 2, 3, 4, 5, 6, 1, 2, 3. Here's my vertex. Oftentimes, mathematicians will put a V next to it to indicate the vertex. And if they're really good, they'll even put the vertex in ordered pairs right next to it. All right, since I know that this parabola is going to be opening up, there's a couple of other things that I might be interested in finding as well. I might want to know where this parabola touches the x-axis. That might be one thing, I'm sorry, not the x-axis, the y-axis. That might be one thing that I'm interested in. In order to find my y-intercept, I would simply replace x with 0. So I would have y is equal to 2 times, this is supposed to be a 0, forgive me, 2 times 0 minus 6 squared plus 3. Well, 0 minus 6 is negative 6. Negative 6 squared is 36. 36 times 2, remembering your order of operations, 36 times 2 would be 74. 74 plus 3 would be 77. That is way off my graph. So instead of using the y-intercept, although the y-intercept is a key feature, 0, 77, although it is a key feature, it is not something that I am going to graph on this grid. Now remember, you have an axis of symmetry that goes through your vertex. That is always true of your vertex. Your AOS, or axis of symmetry, goes through the vertex. So the AOS is x equals 6. Again, I know that this parabola opens up. So what is left for me to do, to be sure, is to make a small chart. I'm just going to make a small x and y chart, and I'm going to plug in a couple of numbers. Now for a parabola, it is symmetric, which means that the right side of the parabola is going to look exactly the same as the left side of the parabola. Therefore, it is not necessary for me to plug in numbers that are on both sides of the vertex. I only need to side with numbers that are on one side of the vertex. So since this is located at 6, I think I shall try 5 and 4 and possibly 3. I'm going to take these values, plug them into my equation, and see what I get. So this is 2 times -1 squared plus 3. That's -1 squared is 1. 2 times 1 is 2, plus 3 is 5. So 5, 5 is one of the ordered pairs on my parabola. Now I'll plug in 2. 2 times -2, I'm plugging in 4. 4 minus 6 is -2 squared plus 3. -2 times -2 is 4. 4 times 2 is 8. 8 plus 3 is 11. All right, we're getting up there. I can try 3, but if it's too large, I'm not going to worry about it. 2 times 3 minus 6 is -3 squared plus 3. -3 times -3 is 9 times 2 is 18. 18 plus 3 is 19, 20, 21. Okay, that is probably going to be off the graph. I am probably not going to include that on the graph. So what I'm going to do is plot this point, 5, 5, because this is a really good, valuable point, and I'm going to plot this point 4, 11. I think my graph can handle that. So if I come over here and count to 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, I know immediately that there is another point on the other side of the axis of symmetry that pairs up with that point. So it is 1 unit away from the axis of symmetry. That means there is an identical symmetric point located right there at 7, 5. I'm also going to graph 4, 11. So if this was 5, 6, 7, 8, 9, 10, 11. So once again, I know that there is an identical point on the other side of the graph located 2 units away from the axis of symmetry. Okay, I make no promises for the beauty of this parabola, but I will try. That's probably about the best you're going to be able to get freestyle. There are graphing calculators that will graph it much better. However, be aware that on your EOC, you may not have access to a graphing calculator. I would like to point out to you once again that the vertex here was at 6, 3. My parabola opened up because it was A positive 2. And if I were to continue going like this, I would probably hit 77 way off the graph somewhere. So I hope this has been a good example of how to graph a parabola that is in HK form.